fifth grade math support. Again, my name is Dr. Griggs, and these are all of our topics that we'll be talking through. We have already finished operations and algebraic thinking, so now we have moved on to numbers and operations in base 10. Okay, so on this one, we've done the first objective. So today we'll be working on the second objective, which is explain patterns in the number of zeros of the product when multiplying a number by powers of 10, and explain patterns in the placement of the decimal point when a decimal is multiplied or divided by a power of 10. Use whole number exponents to denote powers of 10. So let's look at an example. Okay, our problem for today is a factory produces 250 toy cars each day. The manager wants to know how many cars will be produced if the factory runs for 250 times 10 to the first power days, 250 times 10 to the second power days, and 250 times 10 to the third power days. Write the products for each case. Explain the pattern in the number of zeros that appear in the product when multiplying by powers of 10. So first, let's go ahead and figure out our products. So 10 to the first power is simply 10. So if we are multiplying by a power of 10, then we add however many zeros there are. Well, 10 has 1 zero, so we'll be adding an additional 0. So now we go from 250 to 2,500. All right, so 10 to the second power is the same as 10 times 10, which is 100. So 100 has 2 zeros, so that means we'll be adding 2 zeros behind the 250. So 250 plus 2 zeros. So now we are at 25,000. And 10 to the third power is 10 times 10. So 100 times another 10. So 1,000. 1,000 has 3 zeros, so we'll be adding 3 zeros to the end of 250. So 1, 2, 3. So for 3 days, that would be 250,000. We have now written the product for each case. So now let's explain the pattern in the number of zeros that appear in the product when multiplied by powers of 10, which we've already been talking about as we've been multiplying. But whenever you're multiplying by a power of 10, you add however many zeros are in that power of 10. So of course for 10, you would add 1 zero. For 100, you would add 2 zeros. For 1,000, you would add 3 zeros. And this goes on and on and on. So even if you had 100,000 that you were multiplying by, then you would add 5 zeros. 1, 2, 3, 4, 5. So 5 zeros behind whatever that original number was. So now let's say, for example, that we had 2,500s and we were multiplying by the same 10, 100, 1,000. Well, this time, when we think about multiplying by power of 10, we're thinking about moving the decimal place, however many zeros there are. So I'm just going to write this 3 times. And if we do times 10, times 100, and times 1,000. So just like we added zeros when we were multiplying by those powers of 10, now for decimals, we move the decimal place, however many zeros we have, to the right because we're making our number larger because we're multiplying. So that means this one has 1 zero, so it's going to move 1 decimal place. That's going to change this to 2 5/10. This one has 2 zeros, so that's going to move it 2 decimal places. So this will change to 25. This one has 3 zeros, so this will move it 1, 2, 3 decimal places. We'll use a 0 to fill in that extra space. So that means this would be 250. So that's how we would handle if we had a decimal and we were multiplied by powers of 10. If it were division, the decimal would go in the opposite direction. So let's say, for example, we had 2500 divided by 10. Well, there's 1 0, so we will move the decimal 1 place to the left because we are making the number smaller because we're dividing. So then this would become 25 thousandths. So depending on what we're doing, if we're dividing by 10, we're either going to be moving the decimal place however many zeros there are to the left, or if it's a whole number, we will take away if there are zeros. If not, we'll be again moving the decimal even if it's the imaginary decimal that's at the end of the whole number. So that is dealing with multiplying and dividing by powers of 10. I hope this was helpful to you, and if you have any questions at all about this or any other concept in math, feel free to let me know. Thank you so much for watching, and I hope you have a great day. Thank you so much for joining my tutoring session today. If you enjoyed the way that I instruct and you think that I would be a useful addition to your student or to yourself, feel free to scan this QR code. It is going to take you directly to my profile page where you can get set up on weekly classes with me. Looking forward to seeing you in the classroom.